Why is like Kramer the best ever?
Because it's a formula that you can double.
It's a formula that you plug in.
No.
Alright, let's solve elimination, substitution, whatever. We're going to do determinants after this. So let's see if 2x minus 5y equals 1 and 7x plus 3y equals negative 4, let's say. So you know lots of methods of solving. We know substitute, well, graphing, which we don't usually do by hand. Normally we just plug it into the calculator. So you have graphing, substitution, elimination, Kramer, inverse matrices, and now augmented matrices. You're doing this problem on your own. What would you do? You would do a matrix?
Oh, no. I would calculate.
No calculator. Yes, I would use the calculator first for sure. Not an option, Jason.
You make one of the y's and the x's the same.
Okay, what process is that? Not substitution, elimination. Yeah. So make the x's the y's. I always do opposites so you can subtract, but or add. Sorry, add opposites. Which one do you want to eliminate? X or y?
Y.
Okay, great. Why did you choose y? Smaller. Why else? Why should have chosen y? One's positive and one's negative. Sure. All right, let's get rid of y. How do you want to do it?
Multiply 3 by the first one, 5 by the
Multiply the top equation. Yeah, you're right. Multiply the top equation by 3. And the second equation by 5. Yes? All right. 6x minus 15y equals 3. 35x plus 15y equals negative 20. Careful you don't drop the negative, especially if you have not so nice handwriting. Many times this negative just like falls into your equal sign or whatever. All right, what do you get?
41x equals negative 17.
What's x? What's x?
Negative 17.
Negative 17 over 41. Okay, that's kind of gross. Excuse me.
It's a 41.
That's kind of icky, don't you agree? Well, that's great. Still have to find y. Find y without a calculator. Lots of ways to find y.
Did you make this up?
Yeah, I made it up. Of course I made it up. Occasionally, I'll make it up and it'll be nice, but that's rare. It's very rare. What'd you get?
Negative 7.
How much?
Hold on, I'm simplifying.
No, you can't simplify that.
Yeah, it's negative 75 over 205, then you simplify.
Wait, what? Oh, I just don't.
Plug in. Someone please tell me what you get for y.
Oh, oops. Yeah.
Do we not remember?
Negative 15 over 40.
Plug in. I would plug into the first equation probably.
Yeah, negative.
It makes no difference.
Yeah.
It really makes no difference. You want to plug into the first or the second equation? I don't care. All right, Jason spoke up first. Two times negative 17 over 41 minus 5y equals 1. That's not so nice. Negative 34 41sts.
Why is it all of a sudden plus?
Yeah,
Because I made a mistake. Add 34 41sts to both sides. Divide by -5. Do I really have to do that with my calculator? Yeah.
I just did elimination again.
Yeah. No, I
That would have been a much smarter way to go. Shrishti said, I just did elimination again. What's the answer?
I got -15 over 41.
Yeah.
How many of you just did elimination again? How many of you did substitution? What about the rest of you? What'd you do? Sat and waited for us to do it together, so you do fractions. This is a pain. Add 34 41st makes 41.
It actually comes out
75 41sts.
It like
Flexible thing.
it simplifies things.
Is that right? 75 41sts? Divide by -5. Multiply by 1/5. Divide by -5. Multiply by -1/5. 15 over 41.
Oh, 6.
No, 5. That's 5.
No,
that's
you said
six.
5 earlier. It's 6.
Run 6.
Yeah, I don't know, 6.
But
Wait, who bet 6?
if you don't count Soren, then it's 5.
No, no.
If you don't count any of us.
Wait a
Yeah, that's
second.
unfair.
You can't go back on that. You
Oh,
can't
so in other words, you are tardy. Is that what you're telling me?
Wait. You counted me, so you said you could be right, and then now that
Okay, so it comes down to are you tardy or not?
I'm on top.
Well, I mean, if he's not part of the
Then-
on
Yeah,
Yeah, he's in unknown. He's in
right,
unknown.
right behind him.
Okay, that's
The question is, does it really
This is
matter?
unfair. This is what you want.
What's the final answer? Because this isn't it.
I'm not gonna roll.
Why would -17 41st?
Ordered pair. Your answer is always an ordered pair or an ordered triple, depending on what we're solving. Okay, so that's pretty gross. Yes? All right. How do you solve that by graphing?
Mine's like intersection.
You find the intersection, you graph each line, and you find the intersection. How are you going to find the intersection if you're graphing that by hand? How are you going to know the answer is -17 over 41, comma, -15 over 41? If you're just graphing it by hand on graph paper with a ruler, whatever.
You estimate.
You have to estimate. You can't tell me exactly what it is unless your increments are 1 over 41, which you're not going to do. So without the calculator, you're going to get an inaccurate answer. Is your calculator going to give you -17 over 41, comma, -15 over 41? You think so?
Depends on
So Sonab says yes. David says no. We'll look at it momentarily.
I was just shaking my head.
You just do it in your head.
No, I was just shaking my head. I didn't say no.
Okay, Kramer's rule. First of all, let's talk about what is a determinant. How do you find a determinant? No? AD minus BC. CB?
Yeah.
Well, CB.
AD minus BC or AD minus CB?
Alphabetical.
Does it matter? No. What's BC? What's CB? Commutative property of multiplication. 6 times 20, 20 times 6, who cares, yes?
Yes.
So that shouldn't even be a question. So the determinant of this is AD minus BC. So let's go back. Well, where do A, B, C, and D come from? The coefficients on what? The coefficients on the x and the y. The coefficients of the given equation. So in this particular problem, what's A? What's B? What's C? What's D? 3. What's the determinant? What's the determinant?
41.
41? Look familiar from the problem? Look familiar from our answers? Okay. What does that represent in terms of the solution? What does the 41 represent as part of the solution? What is it? What was the solution to the equation that we did by elimination?
Negative 17 over 41, so it's at the denominator.
The solution to this equation, to this system, the solution to this system was negative 17 over 41 comma negative 15 over 41, correct? What's the 41 represent in the solution? The denominator. No fractions, just some multiplication, some subtraction, boom, there's your denominator, 41. Look familiar? Lie and say yes, because I know you learned it last year.
Yes.
This is so familiar.
Okay, I have to find the numerator. So, I think we did this yesterday, X. Now yeah, okay. So your coefficients, A, B, C, D, agreed? And we did the determinant and that told us our denominator. Okay, well we also have to figure out two numerators. A numerator for X and a numerator for Y. N sub X, numerator for X. N sub X is numerator for X. And the idea is, there's going to be some determinant involved. Awesome. Do you remember how to set up the determinant?
I think so.
Go for it.
You go like B.
Close.
Oh, this is for X.
Chloe.
That's
Chloe, why is it close? Yes. Amanda?
You replace A and C so the X values of B and F.
The X values become the quote-unquote solutions.
oh
You had it backwards. That's how you undo Y.
yeah.
And the Y's, the Y coefficients stay the same. So what are the Y coefficients in this particular problem? B and D. These are the given answers. And these are the Y coefficients. They're not the answers to the whole system, they're the answers that are given to you. How do you find the determinant? No! You don't need a calculator, Bobby. Thank you. ED minus FB, BF, whatever. We do not need our calculator to multiply and subtract. Mr. Cobby. Oh, yeah, that's different. We're still not going to use our calculator for that either. It's like a 3x3. Yeah, no, you guys are calling it. How do I find the numerator for Y? I want to find the Y numerator. I want to find the solution for the Y's of this, for the y of this system, how do I do it?
Same thing,
Same thing, sort of.
but use the X coefficient. Or swap.
I'm trying to solve for y, what should go in the y column?
You know,
Yeah, the solutions. I'm trying to find the y solutions, and the answers go in the y column. And what about the x column? Yeah, A and C. Columns matter because otherwise subtraction only matters when you subtract. So if you have the columns backwards, then your subtraction is going to be backwards. So we figured out the denominator for this particular system was 41. Let's figure out the x numerator, which should be negative 17. And the y numerator should be negative 15. Agreed? Okay, let's go for it. What are the x coefficients of that given system way back there?
2 and 7.
2 and 7. What are the solutions?
1 and negative.
1 and negative 4. I want to find the solution for x. The answers go in the x column. What are the coefficients on y?
-5 and 3.
Negative 5, 3. Yeah? All right. I want to find the solutions for the y system. What goes in the x column?
2 and 7.
2, 7. What goes in the y column?
1, -4.
1, negative 4. Negative 15? Yeah? It's not your answer. How do you write your answer?
Coordinate.
Coordinate pair. So what's your answer?
-17, -1, -15 over 41.
Okay, so don't be surprised if you're asked, quiz, test, whatever, to solve by multiple methods. Your answers should all be the same. Elimination, same answer as Kramer. Agreed? Yes? Okay, so let's do one practice, and then we're gonna do 3x3s, then the long way, and then we'll do the calculator. Right, do you have that system written down, obviously? So I can show you by graphing what the calculator does and doesn't do. I believe that most of you have done the graphing calculator stuff. RREF? Talked about this yesterday. Yes, you did, because you had me last year. You absolutely did RREF on the calculator. You had me, for sure. All right, let's go. X minus 6y equals, how about the negative 29? And 5x plus 11y equals, give me a number.
14.
14. Okay, solve using Kramer's. No calculator yet, so now I know it's very tempting.
Wait, so yeah, why would you be like your calculator?
Someone else got his calculator out too.
Oh.
Yours is in your hand.
What?
But like nothing, yours is in your hand.
Did you just
I said we're gonna do it this way, then we're gonna do 3x3 the long way, then I'm gonna show you on the calculator. You could have been done with the problem. Someone else pouting. Puts the calculator.
It's okay. So
Not big. Discriminate.
What's the discriminant? People get these wrong all the time. What's the discriminant?
Denominator.
No, that's a
That's the
determinant.
square root
What's a
thing.
discriminant?
Oh my god. Oh, it's a thing under the.
X equals
It's
negative
the
b minus
thing.
square root. B squared
Oh, b
minus
squared
square.
minus
The
4
square
is
root of b squared.
No, just no
Just
square root.
Oh,
B squared minus
Okay, well while we're here, what's it tell you?
The number of
Oh.
Number of solutions. What else?
It's part of the
real or
It's part of the equation. No, it's got nothing to do with the
Oh wait,
denominator.
never mind. Huh?
It tells you how many solutions, how many real solutions, or imaginary actually. It tells you real or imaginary. I just told you what else it tells you.
Tells you if there's.
Number of solutions and the type of solutions. Real, imaginary. Discriminant is super useful. There's one more nice thing it can tell you. I know this has got nothing to do with Kramer's rule, but someone said the discriminant, so we're going to review it.
It's if it's back.
If it's factorable, yeah. Is factorability a word? It is now. Factorability. Discriminant, super helpful. It has nothing to do with determinants, but it's a super
Oh, is that
useful.
Or positive.
I'm here
Oh, sorry.
reviewing this. Javi, what's your question?
Is the 29 negative?
Yes, 29 is negative. You can figure out 29 times 5 and 14 times 6 and blah blah.
Oh, can I just right? Okay, two. Yeah, yeah. 319. This gets to be 29. Negative 319 minus.
You have a calculator. It's called your brain.
It's a slow board.
It is a slow. It's not necessarily a slow calculator. You know what? The more you use it, the better you get.
I don't know what I do.
The total negative 403.
shoot, that's a lot.
It's only on the 49.
You get nasty fractions along the way.
Yeah.
But I shouldn't say that. You get big numbers along the way. Find the denominator first.
Right.
There should be no sub x. It should just be d. No sub x. 40. Oh, is it 41 again?
Yeah.
You don't have to give us prime numbers.
What's wrong? Actually, prime numbers are nicer. You don't have to worry about any reducing.
Well,
Well, then we also think about whether or not it's
also just like first.
What's the setup for the numerator of x? What's setup?
Yeah.
So what's first column? Numbers. Negative 29, 14, and what's the second column?
6.
All right, well, I don't know what that is, so you can tell me. I don't need a calculator or my brain. I have 21 of you. What is it? Something plus 84
319. Negative 319.
plus 84, or the whole answer.
Wait, isn't it?
Yeah.
Negative 319.
Oh shoot! I realized it was negative 6. 19.
Okay, thank you.
0.
Wait, that
That's
why?
Negative 2.
Negative 235. Yeah? All right, numerator for y. First column,
1, 5.
1, 5. Second column,
Negative 29, 14.
oh, this isn't so bad. 14 plus 30, 150, 145?
Yeah.
Yeah.
169?
59.
Answer? Because it's not an answer. Don't do all the work. and not get full credit because you forget the ordered pair. Don't do all the work and not get full credit because you forget the ordered pair.
Negative 235 over 41, comma 159. 41.
How else to be 41 again? What happens if the denominator is 0? Ugh. 0 in the denominator is an issue. Agreed? Yeah, 0 in the denominator is a problem. Okay, so let's see what happens. Let's just say you have, I don't know, 4x plus, I don't know, 20y equals 12. And x plus 5y equals 3. Yeah, okay. Okay, so hopefully looking at it, what's going on here? It's the same line, same equation. If you reduce the top equation, you get x plus 5y is 3. So they're the same equation, they're the same line. So how do you describe that system? Not continuous. Not discontinuous, David. Inconsistent? Consistent.
Oh.
Consistent. Same line.
Oh.
Discontinuous is like, what do you call it? An asymptote. Like a hyperbola. Hyperbolas are always discontinuous. All those asymptotes you do with the holes and the bouncing and the crossing and whatever, those are discontinuous. The generic definition is if you have to pick up your pencil, your pen, whatever, to draw the graph, it's discontinuous. That's a very generic way to look at it. So this is consistent, infinite solutions, consistent with infinite solutions. What does that look like with Kramer's rule? If I ask you this, if I ask you to solve, the answer is infinite solutions, not consistent. If I ask you to describe the system, then it's consistent. So if the directions say solve, which they will, the directions say solve, then the answer is infinite solutions. If I ask you to describe the system, then it's consistent. So solve, that doesn't mean consistent. That's not a description of the solutions. Okay? It's like undefined versus no solution. It's like undefined versus no solution. What's this look like with Kramer? Always start with your denominator. Always start with your denominator. This is where everything happens. Zeros in the denominator cause issues. So the denominator. 4 and 20. Let's just do the original system that I gave you. Correct? Okay, so there should be a clue to you that this is special. It's like law of science and the ask case, it's special. You have to look out for things. Find the x numerator, find the y numerator, who cares? So choose one of them. Find the x or the y numerator. Which one do you want to do?
X.
All right, x. The x numerator. 12, 3, 20. Which is what?
60 minus 60.
60 minus 60, which is what?
0.
0. The numerator equals 0. The denominator equals 0. Therefore, this is consistent.
Oh, shoot. So you can't say that it's consistent unless you also find the numerator at 0?
Well, they have. How do you know? If it's either consistent or it's inconsistent. So they're either parallel lines or they're the same line. How do you know that without doing the, doing like elimination? You don't.
So,
You can't just automatically say, oh, the denominator is 0, therefore it's inconsistent, or it's undefined. It's not. Undefined does not describe. That's not solving a system. So it's either infinite solutions or no solution.
so do you have to find both numerators?
No, that's it, done. Yeah, Soren.
So I think I'm confused on how you know if it's, like, how can you tell, like, if I don't know how.
Whether it's consistent with infinite solutions or inconsistent. Okay, let's do one that doesn't work, so to speak, where it's no solution, and I think that'll help clear things up. Let's just change one of these numbers. So let's say you have 4x plus 20y equals 12, and you have x plus 5y equals 2. Divided by 4, divided by 4. Okay. So this is no solution. This is no solution. If you divide by 4, you get x plus 5y equals 3 when you divide by 4. X plus 5y equals 3. X plus 5y equals 2. Okay, so let's see what that looks like. So the denominator, 4 and 20 and 1 and 5, which is 0. Always start with the denominator. The difference now comes with, let's just do x again. What would that be? 12, 2, 20, and 5. Okay? Is that right? 60 minus 40, 20. Yeah, 20? Okay. The numerator of x does not equal 0, but the denominator does. Therefore, this is inconsistent. It's an inconsistent system. These are parallel lines. Yeah. These are parallel lines. These are parallel lines. Same slope, different y-intercept, and these are the same line. And then those are just regular old lines that intersect somewhere. Okay? All right, pencil, leave yourself some room. We're going to do a Kramer 3x3. Then I will show you the calculator. You have to know how to do it the long way as well as all the shortcut ways. Okay? Why do I have to do it the long way if I have the calculator? Because I said so. Because that's how it works. All right, let me see here. Where's systems? Well, I'm looking one up that works. From your Algebra 2 honors book, so I know that you had it before. So you can't lie and say you didn't. Triangle properties, trig, probability, sequences. Do you remember all that probability last year? Here we go, systems. Here it is, systems, determinants, Kramer's rule, higher order systems. Here we go, section 4.6. I think by now I know this one. Right down. Two x plus 3y minus z equals 1. No, negative 1, negative 1. That would cause us a lot of grief. Negative x plus 5y plus 3z equals negative 10. Oh, there's too many negatives. 3x minus, no, not 5y. Not 5y. Use a pencil. I made mistakes. 3x minus y minus 6z equals. Okay, I'm gonna read it, you make sure I wrote it down right. 2x plus 3y minus z equals negative 1. Negative x plus 5y plus 3z equals negative 10. 3x minus y minus 6z equals 5. Yeah? All right, here we go. Your homework, you have to do it by Kramer's rule, and if you notice the directions say, page 742, to solve all problems using Kramer's rule and one other method. Graphing, which you can't do with 3x3 on your calculator to graph, substitution, elimination, or matrices. I would do a combination of elimination with substitution. Do you want me to start it to refresh your memory? Do you want me to start elimination to refresh your memory, or we remember how to do threes? All right, well, I'll take your silence to mean you don't need to review it. Kramer's rule. A, B, C, D. AD minus BC, yes? Okay. That's like A, B, C, D, E, A, B, C, D, A, B, C, D, E, F, G, H, I, J, K, L. There's a lot of letters, yes? Okay. We're going to start with, let's write down the coefficient matrix. 2, 3, negative 1. Negative 1, 5, 3, 3, negative 1, negative 6. Oh, Gabby, do you remember?
Okay, it goes 2 times 5 times negative 6.
2 times 5 times negative 6.
Plus 3 times 3 times
Here, the first two statements were correct,
oh,
not the second statement. I
okay.
can't use pink. I need a color that's gonna. Here we go.
Oh yeah, maybe go the other way. Oh yeah.
First row, first column. That's for my little dash lines. This is why you want room. I rewrite a lot. You maybe just want to erase whatever. Where does the first row and the first column intersect? 2. The determinant of what's left. 5 times negative 6, we just did that right here, right? You subtract the diagonals. 5 times negative 6 minus 3 times negative 1. I highly recommend you show work. If you make a mistake and you have no work, I can't go back and see where your error was. Okay? Anybody remember what comes next? What comes next? Ethan?
But you just cross like the top off and like
Down the middle. Okay, so instead of top, you mean row 1?
yeah.
Okay, and the middle, you mean column 2? You're always getting rid of the top row. Where do they intersect? 3. Okay, I'm warning you that I am going to erase. So they intersect at 3. So 3 times, this is not 100% correct. I'm doing it intentionally. All right, find the determinant of what's left. So you've got negative 1, 3, 3, negative 6. What should I multiply? Negative 1 times negative 6 minus what?
3 times.
Minus 3 times 3. What's wrong? What's wrong with it? Do you remember? It's not plus 3. It's minus 3, yeah. It's always the opposite. So if it's plus to start with, it becomes minus. If it's minus to start with, it becomes plus. Yeah,
Then why is the initial 2 not a negative?
because it's opposite. Positive, negative, it's same, opposite, same, opposite, same, opposite, same, opposite.
So not
As
opposite.
the pattern.
Not opposite to the actual.
No,
number.
opposite to what's given. So if this was negative 3, that would be positive 3. So it's the opposite of the coefficient.
So
So if this were a 5, this would be minus 5. If this were a 16, it would be minus 16. If it were a negative 4, this would be positive 4.
so all of them are opposites besides the first.
No, just the middle.
Just the middle.
Just the middle coefficient. It alternates. So if you're doing a 5, which God forbid we should ever do a 5, it would be positive, negative, positive.
What about the next one?
Positive stays the same. Same, opposite, same,
Just
opposite.
the middle.
Second term, don't say middle, because if there's 6 terms, they're not the middle. They alternate. First coefficient stays as is. The next one is opposite. The next one is the same. Then the opposite. Then the same. And then the opposite as you go down. We're not done though. We're not done with just the denominator. And then you need to do it for the numerator of x, the numerator of y, the numerator of z. So I'm going to stick with the first row. And now I'm going to get rid of, Melvin.
Is 3 positive?
So the 3 initially was positive, so now it's going to become negative.
Okay.
Where do they intersect? Where does first row, third column intersect? Negative 1. So I'm going to put the negative 1. Now I'm going to do the determinant of the square that's left. Negative 1 times negative 1 minus 5 times 3. Let's do the math. This is 2 times negative 30 plus 3. Negative 27 minus 3 times 6 minus 9. Negative 3 minus negative 14. 16?
Wait, never mind.
1 minus, yeah.
I said positive.
Negative 54 plus 9 plus 14. How about negative 45? Negative 31.
Yes.
Sure.
Sure. You guys should know by now that I make like a gazillion mistakes. I don't know if I trust me.
Yes.
Copy said yes, so now we trust me. How am I going to find the x numerator?
Same thing as she wants the x.
Yeah, same thing. But we're going to put the solutions in the x column. So we're going to do x, and then I'll give you a break, and then we'll show the calculator. So let's just do x. Actually, you know what? I got a great idea. You guys do x, you do y, and you do z. You guys find x, you find y, and then the bookends find z. Go slow. Work with your neighbor.
My neighbor.
Do the substitution.
Do you want to be my neighbor? Or what's it called?
Won't you be my neighbor?
Oh, yeah. So it's the same thing with the opposites, right?
Absolutely. The difference is the
What are we
columns.
finding? Why?
So to find x, you put the answers in the x column. To find y, you put the answers in the y column. To find z, you put the answers in the z column. Process is the same. I have to see. I think that homework might be a little.
Wait, isn't it positive 6? Wait, wait.
Oh, it's
How many
negative
threes?
six.
Cause it
Shoot.
needs to be the
Oh, no.
15, 19.
Isn't
Just the first.
Just the second one.
It's like 30.
Yeah.
35, 39. Oh, you have two systems of threes. You can do it. You can do it.
I think the one.
You can do it.
Did you get a number? I hope you got a number.
I didn't get that.
Sorry. I didn't
What?
get a number.
No, I told you. Wait, I got one from you. Wait, I think it's probably wrong. I think it's like because.
If you have a neighbor, use them.
Oh, it's positive. It's positive. Because no, but this is -1. Oh, this is +1. Oh, it's negative, but it says it's the second when you swap it. I know I did. So it's +1.
No,
Oh, wait.
it's negative.
Do the
It's a
determinants. You
negative.
cannot work with your neighbor if you're not doing the
I
work.
did 3 times 3. I did 9 on 6.
Is it supposed to be that? I think you're right.
I did 9 minus 6, not 6 minus 9.
What is it?
5 minus 10. You got 62?
No comment.
Yeah, I got 60.
Yeah, I think you're right.
You did it, Tasha?
I think you're right.
Yeah.
Can't work with your neighbor if you're not
Wait,
doing
they
the
both got, what did you guys get?
Well, then you got the last one.
I got 122.
I got 1.
But everyone else got
I
62
got
and
62.
72.
I'm getting. Oh, nice.
Oh, wait.
The answer's nice. You should get something that divides by -31.
I got -62. What you did there?
Wait, okay, it goes 2, -1, -1. -1, -2, 3, 6.
You made it -35.
Oh.
So
See, isn't
there
it?
should have been a positive.
Exact same as a key. This was
Wait.